So we're going to look at a particle motion problem from 2011 where they gave us a velocity equation and an acceleration equation. And A is the speed of the particle increasing or decreasing at time what? 5.5. So we know whenever they're asking us the speed of the particle, if it's increasing or decreasing, we know it depends on the velocity and the acceleration and their signs. So we have to find the velocity at 5.5, and this is a graphing calculator problem, so we just plug it in and we get negative 0.453, and then we get the derivative of velocity, which is the acceleration. This is something I like to write when we're doing, and we plug it in, we take the derivative and we plug in 5.5, math a derivative, and we have 5.5, and you get negative 1.358. And so, but they're both negative, so it's increasing, and we're gonna say at t equals 5.5, speed is increasing because v of 5.5 and a of 5.5 are both the same sign, So this is our reasoning for A. 2 says find the average velocity from 0 to 6. So the average velocity, we know the formula for average velocity is average velocity is 1 over b minus a. You don't have to write this, I will write this, just it's more convenient for me. This is the equation, so we're gonna plug in here 0 to 6, so this is 1 over 6 minus 0, 0 to 6 vt dt. So that once you calculate this, you get 1.949, and this is your answer to B. Now C says find the total distance traveled from time 0 to time 6. So another one where we have to remember the formula. So total distance traveled, we know that the total distance traveled is the absolute value of the velocity. So I'm going to write it here. So from 0 to 6, absolute value of vt dt. So I can't do the calculator here, but I'll tell you how I found the acceleration of the absolute value of vt dt. So basically you put in your equation on y, and then you click math 9, and you get the integral, and then you click math, and there's number, you go to the second part, and the first one that comes up is absolute value, so you put the absolute value, and then alpha trace, you hit whichever equation you put, and then you just click enter. And once I did that, I ended up with 12.573 as my answer. So in this one, we have 2 points, one for showing this equation and one for the answer. So C says, from time 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. So they're asking us to find two things. In order for us to find the position at that time, we have to know when it changes direction, and we know that the particle changes direction when velocity is 0. So even though we know this, we have to write it because we get 1.4 considering this. We have to show that we know this. So velocity is 0 is when they change sign, and in order for us to find this, we are going to find the 0 using the calculator. So velocity equals 0 is when t, okay, so I'll write this. 2. I like this also sine of E04 equals 0. So t is 5.195. And how did I find t equals this value, you may ask? I graphed it. Actually, I graphed the equation, and then you hit second calc, and then you select 0, and then you find the left bound, right bound, and get the 0 when velocity is 0, which is 5.195. So we found that this is the time when it changes direction, and now we have to find the position at this time. So we know the good old formula for finding position at a certain time, which is position at 5.195 equals the position at the initial condition. Then from initial to 195 Vt dt. So in here, our initial is what? X of 0 is 2. This is what they gave us. And once we calculate this, so 5.195 Vt dt is 14.134, and this is our answer. So in D, we were asked to do two things: know when it changes direction, and we did it by knowing when velocity is 0, which is 5.195, and then we were asked to find the position at that time, which is 5.195, and we did it by using the formula by fundamental theorem of calculus, basically, to find the position.